Hello, AP Stat students. I'm going to show you how to do 12.1b, the flower problem, on the graphing calculator. So I'll show you how to do the scatter plot, the residual plot, and then checking for normality using a histogram, box plot, or normal probability plot. So the first thing you want to do is make sure there is nothing in your y equals, and then go to stat, go to edit, and enter in your X and Y values. So enter in your list 1 and list 2. So list 1 is going to be your sugar, and list 2 is going to be your number of hours, I guess, for the flowers to remain fresh. So that is list 1 and list 2. I'm going to show you something because I don't know if you guys remember, but if you want to clear a list, highlight the list and then hit clear, and then just do that. Go scroll down and that'll clear it. So I'm going to go ahead and enter in. So there's 3 zeros, 3 ones, 3 twos, and 3 threes. Okay. And then you want to make a scatter plot of that. So go to second, y equals, and make sure you turn on your number 1. Let's just stick to the first one. So make sure it's on and only that one is on. So select on, and the first graph is the scatter plot. And I never use the second one. The third one is the histogram. Fourth one we use a lot, and that's the modified box and whisker box plot because it has the outliers on there. And then the last one in that row is the normal probability plot. So make sure your X list is your list 1, your tablespoons of sugar, and then L2 is the number of hours that they remained fresh. And then the best way to see everything, if you just hit graph, you don't always see everything, but you have to hit zoom 9, and zoom 9 allows you to see the graph. And there is your scatter plot of tablespoons of sugar and freshness, hours of freshness. Next thing you want to do, you cannot go straight to your residual plot. You must calculate your linear regression equation first. And in order to do that, you go back to stat and you go to calculate and you go to number 8, which is the linear regression equation. Click on it, and we want L1 and L2. So I'm going to change it. So second 1 gives me L1, then you have L2, and then I'm going to store this equation just so I know what the y-intercept and slope are. And to store it, you hit alpha trace, or you can just write it down when you see it on the screen. So I'm going to hit alpha, and then trace is in the very top row, and I'm going to store it in location y1. And then I'm going to go to calculate, and it's going to store that equation. I'll show you where it's stored. But there's your slope is 15.2, and your y-intercept is 181.2. So your equation would be y hat equals 181.2 plus 15.2x. It stores it back here in y equal. And that makes it easier that you don't have to write that equation in. But now if you hit graph, it'll draw your line of best fit. And then you can get rid of the line, which is what I'm going to do. So I'm going to go back to y equals, and I'm going to clear that. But it has already calculated your linear regression equation. So now you can go to second y equals, and at least I hope deleting it didn't not calculate it, but we'll find out here. So go to second y equals and go back to stat plot. And this time we are going to do the residual plot. So to do the residual, the X list is still going to be L1, but your Y list is going to be the residuals. And you don't have a list 3. So to get residuals, you go to second, and you're going to press the word stat. So that brings up the list menu, and you're going to go to number 7, residuals, and then zoom 9, and hopefully it'll do it. Oh, it did do it. Okay. So because it already calculated that linear regression equation. And so that is a plot of your residuals of tablespoons of, and the x-axis being the tablespoons of sugar, and then the residuals plotted. So that is the residual plot. And the last thing we want to do is, what if you're not convinced that the residual and the scatter plot shows that the data are linear? Then you want to do a histogram, box plot, or a normal probability plot. So you go to stat. I'm sorry, you make sure your stat plot's on. So go to second y equals, go to the first graph, and then we are going to do a histogram first. So that's the third graph. Notice when you click on that, it gives you the X list, but we don't want the X list. We want the residuals. So go back to second stat and select number 7 residuals, and then hit zoom 9. And that's what your histogram looks like. It's kind of weird looking. So, I mean, it's not normal, it's not symmetrical, but it doesn't really show any skewness or outliers either. So, if you're not convinced, do another graph. And so, go to second y equals and go back to graph 1. And we are going to choose the modified box plot. And then everything looks good there. Zoom 9. And there's no outliers, but you see some skewness there in the right side over there in the box. So there's some skew. So you're not convinced, go to what I consider my favorite is the normal probability plot. That to me shows the best indication of how data is linear. So go to normal probability plot. Again, everything looks fine. The data list is residual. Go to zoom 9. Oops. There it is. So I don't know what it did, but that looks really good. I mean, you see a little bunching over here on the far right, but it looks fairly linear. And that, to me, that's the most convincing. And so that indicates that the residuals show no strong skewness or outliers. And that's how to do the graph portion. I will do a second video on how to do the calculations when we get to the do portion of our problem. Have a great day.